Okay, guys, in this lesson, we're going to learn how to combine like terms. And if we know our vocabulary, okay, term is a word we've learned before. It's been one of our vocabulary terms. So before we can learn how to combine terms, we really need to know what a term is. What does that mean? Okay, so a term can be any one of a few things in an expression. Okay, so I'll give you an expression. We should know what an expression is. 4x plus y plus 8. Okay, here's an expression, 4x plus y plus 8. Okay, a term can be any one of three things. Okay, it can be a constant by itself. So in this case, your constant is the number 8. That is a single term, 8. Okay, it can be a variable by itself. Okay, so there we have the variable y by itself. We also have one other term, and that is 4x. That's a variable with its coefficient. The whole thing together is one term. So 4x. So in any expression, there are different types of terms. Okay, any coefficient with its variable, any variable by itself, or any constant by itself. Okay, we're going to learn how, if you have multiple of the same type of term, how to combine them to shorten an expression or an equation to make it a little bit easier on yourself. Okay, so that's what a term is. Let's go into how to combine these terms. Okay, so now we know what a term is, we need to understand what like terms are, okay, or terms that are like one another, okay? So we said we had a few examples. I think we had 4x on the last one, y, and 8. Okay, let's start with 8. A like term to 8 is any constant. Okay, any number that's just by itself can be combined with 8. So if I have an expression and it has the number 8, and let's say it has 14, 24, 6, minus 3, any of those can then be combined with this term, 8. Okay? So constants can be combined. All right? The other like terms is if you have a variable. Okay? If the variable is the same and has the same, okay, the same exponent. So, for example, a like term to 4x would be x. It has the same variable with the same exponent. 21x. The same variable, x, as 4x, and it has the same exponent. Okay. Minus 2x. All right. The same variable, x, with the same exponent. As I look at y, okay, if it is a like term to y, it has to have the variable y with no raised to no value, okay? So 12y, 11y, another term in the same expression that has the value of just y. Those, okay, are like terms. All right. How do I know if they're not like terms? What if they're really, really similar? All right. How about this? I'll put it in red. Okay. 4x. Some people may think that 3x squared is a like term to 4x. It is not. These are not like terms. The reason being, okay, is because you have the same variable x, but it's raised to a different exponent. It's squared. So these are not like terms. I would not be able to combine them. All right. How about 4m? Another common mistake. Okay. If I look at 4x and 4m, their coefficients are the same, 4 and 4. But that's not what we need to look at for them to be like terms. The variables have to be the same. So if this one's x, this would also have to be x and raised to the same power. Okay, but this is m, so they are not like terms. I cannot combine them. The same goes down here. Okay, if I said 2y to the third, all right, y and y are the same, but this is not raised to a power, this one is. So these are not like terms. If I just got something along the lines of y squared, I cannot combine y and y squared because this is y and this is y, but this one is raised to the second power where this one is not. Okay. How about this one? 8r. The numbers are the same, 8 and 8, but what's different? Well, this one has a variable r, this one does not. Okay, constants can only be combined with constants. 14, 24, 6, -3. They cannot be attached to a variable to combine them. Okay? So that's how we determine whether they are or are not like terms. Okay? Now, let's look at an expression and let's start to combine them. Okay, looking at a problem like this is a prime reason why we learn how to combine like terms, because this is a lot to look at. Okay? But if I can take the terms that are common and put them together, it really shortens this thing up. So here's how we do it. The first thing we're going to do is we're going to look at the first term. And you'll notice if we really look, okay, we can count the amount of terms there are. There's 1 here, okay, 2 here, above the 2, minus 3y is a third, plus 2x is a fourth, and minus 4x squared is the fifth term. There are 5 terms in this expression. Okay, let's see which ones we can combine. So the first thing I'm going to look at is 5x squared. All right, is there anything in the next 4 terms that I can combine with 5x squared? All right, remember the criteria is it has to have the same variable with the same exponent. So as I look at this, it has to have x as the variable, and it has to be raised to the power of 2. Well, 2 is a constant, so it does not have a variable in this term. Minus 3y. Okay, y is the variable. Well, that's not x, so we can't combine that. How about this one? Plus 2x. Okay, this is not a like term. The reason being, yes, both the variables are x, but this one is not raised to the second power. This one is, so they're not like. So let's look at the fifth term, minus 4x squared. Well, the variable is x, which is the same, and the exponent is 2, which is the same. So this minus 4x squared, we have to pay attention to the operation out in front, can combine with 5x squared. So I'm going to rewrite those. 5x squared and minus 4x squared. Okay. So now that I'm done with those 2 terms, I can look at the next term in the expression. It's plus 2. All right. Well, we're looking for another constant because there's no variable here and no exponent that it's raised to. So all we're looking for is another number left by itself. Well, the next term is minus 3y. That has a variable of y, so that's not it. And plus 2x. Well, that has a variable of x. So neither of these are like plus 2. So that one's on its own. So I'm going to rewrite plus 2. There's nothing I can combine it with. Okay? Now, let's look at the next term. Minus 3y. So there's only one other term. We need to determine, does it have the same variable raised to the same exponent? Well, this is y, and this is x. So it does not. So we leave it alone. Minus 3y. And the last term is plus 2x. And that is the last term. There's nothing to combine it with. So we simply write it out. Okay. Now we can combine. Now that I've broken everything down. All right. So we look at it. 5x squared minus 4x squared. Okay, that's 5x squareds, and I'm taking 4x squareds away, so I'm left with 1x squared left over. The rest of this I can write down. There's nothing to combine. Plus 2 minus 3y plus 2x. Okay, and if we know that 1 times x squared is just going to come out, because anytime you multiply anything by 1, okay, it's going to come out that number. We know that 1 times x squared is the same thing as saying x squared plus 2 minus 3y plus 2x. If you leave the 1 there, it's not a big deal. So if you were kind of confused by that comment, ignore it. All right, but just know that 1x squared and x squared are the same thing. Okay? All right, let's do another example, guys. Okay, so this example, right, is going to have a little bit more combining to do in it. All right, I just wanted on the last one to show you the difference between x squared and x. Okay, this one, we're going to take a look, and again, we can count out the terms that we have. Okay, so variable by itself, a variable with a coefficient, or a constant. That makes up a term, remember? So x is a term, 2y is a term, 6x is a term, 8 is a term, 7y is a term, 3 is a term. So there are 6 terms. We're going to see which ones combine. So the first thing we're going to do is look at our first term. It's x. All right, and we're going to look for another variable raised to the same exponent, which in this case, it's not raised to anything other than just 1. Okay, so y is not the same as x. X is the same as x, and look, it's not raised to another power. So this works. So plus 6x, remember, we want to pay attention to that. 8 is a constant, so it doesn't have a variable, so it can't combine. Y is different than x, so it can't combine. And 3 doesn't have a variable, so it can't combine. So we're looking at x and plus 6x combined. So we go x plus 6x. Okay? Let's look at the next one on the list. The next one is 2y. All right, so we want to look and see, is there another term here that has y as the variable that's not raised to any power? Okay, the next term that we haven't used yet is 8. It's a constant, so it doesn't have a variable, so it's not going to match. Plus 7y. Y is the same as y, and they're both not raised to a power other than 1. Okay, so plus 7y does match plus 2y. And then 3 is a constant, so it's done. Okay, so let's write those down. Plus 2y and plus 7y. Okay, now we're left with 2 terms after the fact. We have plus 8, and the last term is plus 3. They are both constants, so they are like terms. Constants are always like. Okay, so we have plus 8 and plus 3. Now I can start to combine these. All right. If I have 1x and I'm adding 6 x's to it, that means I have 7 x's. All right. If I have a positive 2y, so plus 2y, and I'm adding 7 more y's to that, 2y and 7y is 9y. Then if I have 8 and I add 3 more to it, 8 and 3 is 11, and they're all positive, so I just put a plus sign here. Okay, 7x plus 9y plus 11. Notice, what did I do? When I combine them, I either add or subtract the coefficients. Okay, if x is alone, the coefficient is 1. Or if y is alone, the variable is alone, the coefficient is 1. So I have 1x here, and I'm adding 6 x's to it. That's 1 and 6. Added together is 7. I have 2 y's here, and I'm adding 7 y's to it. So I add the 2 and the 7, I get 9. Okay, and then just to add 8 and 3, we should know how to do. All right, that's that, guys. That's combining like terms.